So the topic that we're doing today is 3-3. It is sort of a mismatch of a couple different random things. All right. Um, the first thing is converting Fahrenheit and Celsius. All right. There is a formula that you are given. You're given C equals 5/9 times F minus 32. So that's going to be the formula that we're going to use for converting Fahrenheit and Celsius. All that you're going to do is you're going to be either given Fahrenheit or given Celsius. You have to sub it into the formula and then solve for the missing variable. We're just going to round to the nearest hundredth if necessary. All right, so that's 2 decimal places. So this first one says 100 degrees Fahrenheit. 100 degrees Fahrenheit, that means we're going to stick this 100 into the F in the formula. So I'm going to have C equals 5/9 times 100 minus 32. So when you take a look at that, you could actually type this right into the calculator, 5 divided by 9, and then parentheses 100 minus 32, close your parentheses. You could just type that right into the calculator, and you would really get 37.77777777777, or 7 repeating. We're going to round to the nearest hundredth, so we would actually put 37.78. For the next one is 10 degrees Celsius. So instead of subbing it in for the F, this time you're given the C value. So you're going to sub it into C in the formula. So instead of C equals, we're going to have 10 equals. And then you have 5/9 times F minus 32. So you have the rest of the formula. So the first thing that I would personally do to solve this is we need to get rid of the parentheses. But first we need to get rid of the number that's in front of the parentheses. If you think about yesterday's lesson, we were multiplying by the reciprocal to get rid of that fraction. So that's the same thing that I'm going to do here. I'm going to do times 9/5 and times 9/5. That way these will cancel out. Now 9/5 is really just the decimal 1.8. That's really what 9/5 is. So we have 1.8 times 10, which is 18. On the right-hand side, those fractions canceled each other out. When we bring this down, we're just getting rid of the parentheses because they're not necessary anymore. And we have F minus 32. We now need to solve that one-step equation by doing plus 32 and plus 32. So we get F equals 50. So there was one example of each. Go ahead and try both of these on your own, please. Go ahead and try both of these on your own, please. Remember to sub in the F for the F spot and the C for the C spot. Going to give you about 30 more seconds. Please do both of these questions. So in this first one, you are given the F. So you're going to sub that in to there in the formula. So you're going to have C equals 5/9 times 80 minus 32. Again, you could just type that right into the calculator. 5 divided by 9, and then parentheses, 80 minus 32, close your parentheses. When you do that, you really get 26.6 repeating. Remember, the directions said to round to the nearest hundredth. So this 666666666 at the end would really round to 26.67. For the other one, we need to take this 8 degrees Celsius and sub it in for C here. So instead of C equals in the formula, we're going to have 8 equals in the formula. Then we're going to have the rest of the formula 5/9 times F minus 32. So now we want to solve that. We want to get rid of that fraction. All right, we want to get rid of that fraction by doing times 9/5 and times 9/5. Goodbye, goodbye. Those cancel out. Remember that 9/5 is really just 1.8. So we have 1.8 times 8, which gives you 14.4. Bring down the rest that we didn't use yet, but get rid of those parentheses. We don't need them anymore. So we have 14.4 equals F minus 32. To solve for F, this is just a one-step equation. Plus 32 plus 32. So we get 46.4 equals F. Does anyone have any questions on those? Literally all that you're doing is taking numbers, subbing them into the formula, and solving for the missing letter. So the next kind of problem that we're going to have today looks like this. We're going to talk about linear functions and the distributive property. Now remember, the distributive property is where you have a number outside the parentheses and then something inside the parentheses like x plus 10 or 4x minus 2 or something like that. So we're talking about linear functions and that distributive property. We're actually going to set up linear functions that look like this, f of x's that look like that. So the word problem says a factory produces glass bottles that sell for 25 cents each. So every glass bottle that they sell is 25 cents. Every hour, there are 10 bottles that break. Write a linear function that represents the total amount that the factory earns selling bottles, taking into account the bottles that break. So they want a linear function. So we're going to have the f of x equals. And now each bottle that they sell is 25 cents. So normally what you would do is you would just have 25 cents times x. However, they're telling you that 10 of the bottles that they produce every hour are breaking. So we can't just have 25 times x, 25 times the number that they're producing, because they're breaking 10 bottles every hour. So we're not just going to have 25 cents times x. The actual number that they're able to sell is the number that they're able to produce minus 10. So if they produce x per hour, the total that they're able to sell is x minus 10. So this is where we get the distributive property, because our x is how many they're able to produce, but then we have to take away 10 of them, because 10 of them they can't sell because they're broken. If we would distribute and distribute here, we would have 0.25x minus 2.5 equals the f of x. So that's what we are doing there. You're not solving anything, you're just setting up the linear function. Let's take a look at another one. May paints and sells ceramic vases for $35 each. Each month, she typically breaks 3 vases in the kiln. A kiln is what you make pottery in, right? You have to fire it and to harden the clay. So each month she breaks 3 of them. Write a linear function that represents the total amount that she earns each month selling vases, taking into account the value of the vases that she breaks. So again, we're going to have a linear function. So we have the f of x equals. Now, normally, if we were just going to figure out how much she earned by selling vases, we would just do 35 times x, so 35 times the number of vases. Well, because she's breaking 3 vases each month, we need to take away 3 from that x. So this is really going to be 35 times x minus 3. When we go to distribute, to simplify it, we would have 35x minus 105 when we distribute. Don't make this harder than what it is, all right? Yes, it's pretty easy. Just do it exactly how it says, all right? All the questions are done the same way there. Now, the next part of your homework today looks like this. For each of the following, write a function in slope-intercept form. So slope-intercept form looks like this. Y equals mx plus b. Remember that the m is your slope, all right? That can be written as a fraction or not as a fraction. And then your y-intercept is your plus or minus whatever is your b value. But we want our equations to look like that. Remember, instead of using y, you could also use f of x equals. So in number 1, in order to join a dancing club, there is a $30 startup fee and a $4 monthly fee. So you have to pay $30 just to join, and then every month you have to pay $4. How much will it cost for a year? So when I go to set up my initial function, all right, I'm going to have f of x equals, and now we want it to look like this. We want it to look like this mx plus b. All right, that's the form that we wanted it. So you're paying $30 just to join, but then you're paying $4 every month. So $4 times the number of months plus the $30 startup fee. Now you might have thought, well, couldn't I put 30 plus 4x? You could, but it asks you to put it into slope-intercept form. So we really want that plus 30 at the end, not at the beginning. Yes, it is technically the same thing, but they want it in this specific form. So that would be our answer there. Now, how much will it cost for a year? Be careful. You might get tricked. A year is one year, but we're not talking about years in the problem. We're talking about months in the problem, right? In the problem, it says that there's a $4 monthly fee. So there are 12 months in a year. So we are not going to sub in 1 for 1 year. We need to sub in 12 for 12 months. So we're going to sub that into our equation. So 4 times 12 plus 30. 4 times 12 plus 30 gives you 78. So for 1 year, with the startup fee and the monthly fee, it would cost $78 total. In question number 2, it says, in order to join an online learning community, there is a $20 startup fee and a $5 monthly fee. So let's write the function first. So for function, we're going to do f of x equals. There is a $20 startup fee, so your initial payment of $20 plus $5 every month. So $5 every month plus the $20 fee. So that's what that looks like. In letter B, if Sarah has $175 to spend on joining, how many months can she participate? Now be careful. Think back to when we did the lesson of f of 5 or f of x. Be careful of where you're subbing this 175 into. Over here, we had the number of months. We wanted the total. This time, you're being given the total, and we want to find the number of months. So 2 totally different problems. This time, instead of f of x equals, we need to sub in that 175 for the total. So instead of f of x equals, we have 175 equals 5x plus 20. And now you just have a 2-step equation. So minus 20 minus 20. So we have 155 equals 5x. Divide by 5, divide by 5, and you end up with x equals 31. So she can do it for 31 months. So be careful on these. Sometimes you're going to sub it in for the x. Sometimes you're going to sub it in for the f of x. It all depends on the problem situation. So be very, very careful there. So there are 3 different kinds of problems today. All right. Make sure that you're subbing it into the right spots. That's sort of the main point of the lesson between Fahrenheit and Celsius and this stuff. Also setting up your functions. Let's take a look